Welcome back. We've looked here at the claim that the majority of Americans who can vote do vote, and we want to make the null hypothesis and the alternate hypothesis. And these two will combine to give us a testable hypothesis, a working, right? Basically, the null is going to be our working assumption, and the alternate hypothesis will be our testable hypothesis. We'll see that as we go. But again, the claim is that the majority of Americans who can vote do. And the null hypothesis, the focal point, is a single value that we can take. And for majority, that is more than half. So the null hypothesis would be to say exactly half of eligible voters actually do vote. And since we want to go beyond that and find greater than, right, we want to see if the majority of voters actually vote, our alternate hypothesis, the one we're going to really see if it holds up or not compared to the null, will be p greater than 0.5. And that's going to be how we deal with that. So if you found that, well done. Pat yourself on the back. I'll give you, okay, that's enough. Stop patting yourself on the back. You've done it. So what happens next? We've got this hypothesis. What are we going to do with it? And really, I just want to give you a heads up for what's going to come up in the next several videos here. After you've found or you've made your testable hypothesis, you've got your null, your working assumption, and you've got your alternate, the one you're trying to see if it's more viable than the null, you will first decide on your significance level. How reliable or how big a deal do you need it to be in order to reject your hypothesis or not? Once you've decided on that, you'll get a sample, and then you will do a test. And we'll talk about that in a crazy amount of detail. And then finally, we'll form the conclusion. That's going to be our process start to finish. So let's say we do that. We've decided on significance level. We've decided on all that good stuff. And we actually got some samples. I did it 3 times. These are all hypothetical. And let's say I did it once with 1,000 people and they were all eligible to vote. And only 530 people of that actually voted. Now, that is the majority, right? That is the majority. So this sample does support the claim, but does it prove the claim, right? Does it show convincingly that the majority of all Americans vote? Hard to say. On the other hand, these other two are pretty interesting because if only 53 of 1,000 people who are eligible to vote actually vote, I would really recommend that you don't do hypothesis testing here because it is so obviously significantly low compared to 50% that there's just no point to hypothesis test because it's obviously not going to fly. On the other hand, if you do 1,000 people and 953 people vote, then it's so obviously supporting your claim that there's, again, no point to hypothesis test. But this 0.53 sample proportion, this p hat of 0.53, we can go either way on that. We can. There's something to think about. Something to think about. Another example for you here. A news reporter said that 30% of adults have, at some point in their life, sleepwalked. So we want to test this claim. So to test this claim, and this is actually going to be something we will work through this entire series. So at the end of every part, I'm going to come back to this example. 30% of adults have sleepwalked in their lifetime. To test this claim, we need a null hypothesis and an alternate hypothesis. Now, since the claim is that the proportion who have sleepwalked is 30%, our null is, of course, focusing on 30%. And since the claim is that exactly 30% do it, our alternate hypothesis will be not that. It'll be p not equal to 0.3. Had the claim said at least 30%, then we would still have the same null hypothesis, but now our alternate would be p greater than 0.3. But that's not what was said, so it's p not equal to. And hey, we've got a working hypothesis now. We know how to do that. So next up, we've got to decide on significance. I'll see you in the next video.